Okay, we're going to have another example here. We're going to practice a technique called logarithmic differentiation. Now, the idea is that to create, using a log, we're going to create an expression that's maybe a little bit simpler to differentiate. If it seems like you're working a problem and that's not happening, then you wouldn't use logarithmic differentiation. There are some problems that we're going to see later that can only be done using this technique. So this is an important technique, and you should just watch what we do. So we'll take the natural log of both sides of this function. And then, so now we don't have an explicit function for y, we have an implicit function. And we'll differentiate it as such. So now, before we do that, what we can do on this right side is bring out that half power and just have this. Okay, and so I have that. Now I still have to differentiate this thing, so I don't really want to use the quotient rule in here. I can, but if I want to avoid that now, I can take advantage of my log form and use those properties. Okay, so now probably a good idea to jump in and differentiate. Now on the left side here, I'm going to have y prime over y. Okay, y prime is the same as dy dx. Just a little bit easier to write it, so I did that. This side over here, I'm going to have a 1/2. I want the derivative of the natural log, so it's 2x over the x squared minus 1. And then this one is minus 1/2 times the 2x over the x squared plus 1. So those are the derivatives. That means y prime will be multiplied by y. I'll have a y over 2, and I'll have a 2x over x squared minus 1 minus 2x over x squared plus 1. So there's a few more things that we could do with simplifying, but we have the derivative now, and we could rewrite it to make it look a little nicer. There's a few things you can do here. The more you do, the less it seems like we actually need it. We really didn't need logarithmic differentiation for this problem. I just wanted to show you how it's done. But now we'll have to put our functions back in here. Okay, first of all, I'm going to cancel that 2 just because it can be canceled. And our function was at square root of x squared, yeah. So all of this is the square root of x squared minus 1 x squared plus 1. And we have, I'm going to put these together here. I guess we could factor out that x out in front. And just put these together, x squared plus 1 minus an x squared minus 1 over x squared minus 1 times x squared plus 1. So I'm going maybe a little farther than I need to here, but I'll get the job done. It looks like we just have inside here, just a 2. So I guess we could write that as 2x. We'll put that x back inside. And now you've got this x squared minus 1 to the half. And down here, you've got x squared plus 1 to the half. And then an x squared minus 1. And then an x squared plus 1. So we can continue a little bit further. We'll have a 2x. This term here, this factor down here, we can write that as x squared minus 1 to the half. And then the other factor down here is this x squared plus 1 to the 3/2. But that's it. That's about it. And I spent a lot of time just simplifying. I didn't have to go that far with it, but I did. Okay, so that's a logarithmic differentiation, and it will be necessary in some other problems. Here, it was optional, didn't really need it.